Welcome to another interesting video from Study Clips Library. Numbers. They're everywhere. We use them every day. Think about it. How old are you? How much does that pizza cost? Numbers tell the story. Imagine a world without numbers. Chaos. We couldn't track time, measure ingredients, or even count the stars. Numbers are the unsung heroes of our world, quietly keeping everything in order. From the moment your alarm clock goes off to the time you count sheep before sleep, numbers play a vital role. They help us make sense of the world around us, providing a framework for understanding and navigating our daily lives. The world of numbers is a bit like a family reunion. You've got your familiar faces, like the natural numbers, 1, 2, 3, and so on. They're the numbers we learn as kids, used for counting. Then you've got the whole numbers, which include 0. 0 is a big deal. It represents nothing, but it's a very important concept. Imagine trying to write 10 without 0. Integers bring the negatives to the party. -3, -2, -1, 0, 1, 2, 3. They're great for representing things like temperatures below 0 or debts. Rational numbers are like fractions and decimals. Think pizza slices. You can have half a pizza or 0.5 of a pizza. Same thing. And then there are the irrational numbers like pi, which goes on forever. These numbers can't be expressed as a simple fraction, making them a bit of a mystery. We usually use the decimal system based on the number 10, but did you know computers speak binary? It's a system with just 2 digits, 0 and 1. Think of it like a light switch, on or off. That's binary. It's how computers store and process information. Amazing, right? And who could forget Roman numerals? IVXLCDM. They might seem outdated, but they're still used today for things like numbering chapters in books or Super Bowl titles. Understanding different number systems is like learning a new language. It opens up a whole new way of thinking about numbers and their uses. Ever heard of a square root? It's like finding the number that, when multiplied by itself, gives you the original number. For example, the square root of 9 is 3, because 3 times 3 equals 9. Surds are a bit trickier. They're square roots that don't simplify to a whole number. The square root of 2, for example, is a surd. It's about 1.414, but it goes on forever. These concepts might seem abstract, but they have real-world applications. Architects use square roots to calculate building dimensions, and engineers use them to design bridges. Section 5. Exponential power. Understanding the laws of exponents. Exponents are a shorthand way of writing repeated multiplication. For example, 2 to the power of 3, written as 2 cubed, is the same as 2 times 2 times 2, which equals 8. There are laws that govern how exponents work, like how to multiply or divide numbers with exponents. These laws are important in fields like finance and science. For example, compound interest is like an exponent in action. It's how your money grows over time when you leave it in a savings account. Section 6. Sets and Venn diagrams, organizing information effectively. A set is simply a collection of things. It could be a set of numbers, colors, or even people. Venn diagrams are a visual way of representing sets and how they relate to each other. Imagine 2 overlapping circles. Each circle represents a set, and the overlapping region represents the elements that belong to both sets. Venn diagrams are super helpful for organizing information and solving problems. For example, imagine you're planning a party. You could use a Venn diagram to figure out how many guests like pizza, how many like ice cream, and how many like both. Section 7. Big and small, mastering scientific notation. Scientific notation is a way of writing really big or really small numbers in a more compact and manageable way. It's like shorthand for scientists. For example, the speed of light is approximately 299,792,458 meters per second. That's a mouthful. In scientific notation, it's written as 2.99792458 times 10 to the 8th meters per second. Much easier, right? Scientific notation is used in fields like astronomy, chemistry, and physics to express extremely large or small quantities. Section 8. Absolute value measuring distance regardless of direction. Absolute value is simply the distance of a number from 0, regardless of whether it's positive or negative. Think of it like measuring the distance between 2 points on a ruler. For example, the absolute value of 5 is 5, and the absolute value of -5 is also 5. The symbol for absolute value is 2 vertical bars around the number, like this 5 equals 5. Absolute value is used in everyday life when we talk about things like temperature differences or distances traveled. Section 9. Patterns and predictions decoding number sequences. Number sequences are like puzzles waiting to be solved. They're lists of numbers that follow a specific pattern or rule. For example, 2, 4, 6, 8 is a simple arithmetic sequence where each number is 2 more than the previous one. By figuring out the pattern, we can predict the next number in the sequence. Number sequences are used in cryptography, computer science, and even music. Understanding number sequences helps us recognize patterns, make predictions, and appreciate the elegance of mathematics in our world. Sequences are the building blocks of patterns in mathematics. From the steady march of linear sequences to the accelerating curves of quadratic sequences and the exponential leaps of geometric sequences, each follows its own unique rule. But how do we uncover these rules? First, we observe the pattern, then justify it by identifying its structure. Finally, we prove the formula step by step, turning a simple list of numbers into a powerful mathematical insight. Every day we solve problems, big and small. Imagine planning a road trip. Flowcharts and algorithms can guide you step by step from mapping your route to calculating fuel stops. They're like a GPS for problem solving. Now think about real-life connections, like baking. Doubling a recipe? That's direct proportion. More ingredients mean more servings. But if you're sharing one pizza among friends, fewer slices per person means more people can eat. That's inverse proportion. These concepts are the secret sauce behind efficient problem solving and understanding relationships around us. Hope this video helped in understanding the practical applications of this topic. For more such educational videos, subscribe to studyclipslearning.com.